it's part of the inquiry and nature science category. It's a very hands-on type of event, not really like a study one with binders and cheat sheets. It's more like you're actually building an experiment during the 50-minute time slot you have. Um, is there an echo? Oh, okay. Okay, never mind. So for Science Olympiad, there's three things you need to do to get the best score. Um, you need to first design an experiment. So they'll give you a topic, and you're going to have to design an experiment based on that topic. Then you have to actually conduct that experiment with the materials you have, actually conduct it, and then report on it with like observations, conclusion, possible errors, and that stuff. Um, yeah, so the materials, since we've been doing it like online, sometimes in person, usually we have to provide our own materials, but they'll give the set of materials before. Or if you're doing an in-person event, they'll give you the materials there, and you're just gonna have to design, and conduct an experiment there. Okay, so you can use for the event. You have 50 minutes to design, conduct, and report the experiment. You can use one timepiece, one linear measuring device, and one non-programmable, non-graphical calculator during the 50 minutes. I can just share the rules for you guys so that you guys can access it on your own device. It'll be easier. Okay. Okay, I sent the rules in the chat so you guys can look at it. It basically is the rubric for how the judges are going to be grading you. So you have to make sure you get the most points, and it basically tells you exactly what you need to do to get a point. So as long as you follow the rubric, you should get a good grade. That being said, you won't have this rubric in front of you while you are testing. You just kind of have to memorize it before. And there's two sections for experimental design. Um, you'll have the design and the actual construction of the experiment, and then the second section will be the data analysis and conclusion. So your graphing, your statistics, analysis, all that will go in the second part. Okay, that's just a rough idea of how it works. Okay, some example topics. So they're going to give you a topic. You'll just get like one of these topics you see here, could be more too. And you're going to have to design, conduct, and report an experiment based on these topics. So these are just some example topics that they might give, and you'll only have access to these topics when you start the test. So you must have a rough idea on example topics, so it's a good idea to practice some example topics before entering the test and scientific explanations for each. So in the chat, you guys can all write, what do you think capillary action means? This could be one of your topics. You'll have to design an experiment based on that. So type in chat what you think it means. Okay. Yeah, there's some good answers here. So capillary action is the is a process during which a liquid like water moves up something solid like a tube into, or it doesn't have to be a tube, it can be a material with a lot of small holes. This happens when three forces called cohesion, adhesion, and surface tension work together. So that's capillary action, just basically liquid water just moving up a tube like that with lots of small holes. You can see like I should have put a better diagram on here, but if you just search up capillary action, you can get like some good diagrams of how it works. So that could be one of your example topics, and you have to make experiment based on that. So you could do stuff with like paper and like watercolor and see like if the water goes up. Um, Part one is the design and construction of the experiment. So the first thing you're doing is the statement of problem. It is a question that defines the topic of experiment and relationship between two variables, the independent variable and dependent variable being tested. So one example of this would be, how does the independent variable affect dependent variable? This is an example. This is going to be the experiment we're using for all examples today. So how does the height a ball is dropped from 3 meters affect its rebound height in centimeters? So as you can see here, the height a ball is dropped from is your independent variable, and the rebound height is your dependent variable. You have to include, it's a good practice to include units. It'll really help you as you keep going. With that, can you guys all write your own statement of problem using these templates of any scientific, like scientific topic that you know in the chat? So make your own statement of problem using the templates. Yeah, how does the amount of cesium in water affect the height of the explosion? That's a really good one. Okay, I'm seeing some good examples. Yeah, that's basically the rough idea of how you make a statement of problem. Of course, you'll make it depending on the topic that they give. Okay, next next thing is the hypothesis, which is the proposed explanation or generalization on trial. So the format is, if I change the independent variable, which in our case is the different heights. If I drop a ball from different heights, 3 meters, and the rebound heights in centimeters for the higher drops will be greater than the lower drops because, and then your rationale comes. So you basically are proposing an explanation. So what is a rationale? Type in it in the chat. So you can kind of deduce it based on the example and the format, but what does rationale even mean? Yeah, the justification or reasonings for your hypothesis. You have to include the rationale. As you can see in the rubric in the top right corner, there's 2 points just for rationale. So it's a very good practice to include rationale in all your hypothesis. Okay. Variables. Independent variable that is changed during the experiment to examine the effect on the dependent variable. In our experiment, it's a drop height, 3 meters. Our dependent variable is what is affected, what is being measured in the experiment, which would be our rebound height. Controlled variable is the factors which could affect dependent variable but are kept constant. So for example, size of ball. These could affect our experiment, but we keep them constant just for the purpose of our experiment. Shape of ball, material of dropping surface. Constants, these cannot be changed because it cannot be controlled. So things like Earth's gravitational acceleration or like sunlight, if you're doing like a plant kind of experiment, then yeah. Go back one slide. Yeah, sure. Okay. What is the difference between controlled variable and constant? So this is a very, like if you can see in the rubric, you have to have both controlled variables and constant, but how do you make sure that you don't like switch them around? What is the difference? Any ideas of what the difference is? Yeah. Yeah, the answers that are coming in are all good. Okay. Materials, probably the easiest part of the experiment. Items used to conduct the experiment should be as specific as possible and quantifiable. So a lot of mistakes that people do is they don't quantify their material. So if I can show you guys here, 3 pen racquetballs. You see how we put the three? We have to specify the amount that we're using. Otherwise, you can get points off. So yeah, so all materials are listed and quantified like this. A quantifiable material. This should be very, very simple. Just type in a quantifiable material. Yeah. Okay, but ball and food isn't quantifiable, right? So like you have to put in like a number either or yeah. Okay. Yeah, the answers that are coming in good. Procedure or setup. And setup. So this is the list of steps in an experiment. It's labeled diagrams of how experiment was performed. So you can see here an example setup diagram. You'll actually have to do this on paper, like, and then submit a picture if it's online. But yeah, this is right. Oh, wait. Right on the bottom right, you see kind of a format of how things work. You say your step one, your step two, your step three, and at the end, you have to repeat the steps for different trials. Because as you can see here, number three in the top right hand corner for the rubric, we have steps for repeated trials, so we have to make sure we include that. So an example for our experiment is this right here. You can see steps 4 and 7, where we indicate that we're going to repeat the steps before, so we get like we get data certainty. Okay. Oops. Um, Qualitative observations. So, as you're performing your experiment, you have to make some observations. Like, you have to use your senses to observe results and collect data. So, while the experiment is going, you're gonna make observations before your procedure, during your results, after your procedure, and after your results. So, as you can see here, this is um, kind of a table for our experiment that that um, that shows your all your qualitative observations. And notice how the rubric says you have to provide for the procedure and for the results throughout the course. You can't just do during the experiment, you have to do before and after as well. Okay. Um, this is data table. It's a way to organize numerical data. You have to make sure you remember units and titles. As you can see here, it's worth 2 points of just having units. So it's good. You have to make sure you add units. And this is kind of right here this is kind of how on the bottom left, you see for our experiment, they did trial one, trial two, trial three, and then they took an average, which is another data table. And then you have to give you have to give a sample on how to calculate it. As you can see on the top right where the rubric is, it says example calculations for derived variables are given. So for the ones that you're deriving, like average, you have to give a sample formula and with actual numbers. And they should have used units when they're calculating the sample, but they didn't. Um, yeah, and then you can see on the other data table, this is for a different experiment, but you can see how they very organizedly did a data table and they calculated the average after with the initial weight, final weight, mass of water held. Okay. This is part two, so now you'll kind of this is kind of where the point where you'll stop doing actually conducting your experiment and start moving on to like analyzing and reporting. Okay, so this is a graph. So based on your data table, you're gonna have to make a graph on it. So you can see on the left how drop height affects rebound height. On our x-axis, we have our drop height, and on the y-axis, we have our rebound height, and we have units for everything. This is kind of the steps of what you use to get all points on graphs. You label your axis, you title your graph. Remember, it's 4 points of just having your labels right, and titles right. So you have to make sure you get these down. Use the dependent variable as your y value and an independent variable as your x, and then title each individual axis, connect the data points, or draw a line of best fit. Only include the averages of the data for each independent variable. So as you can see here, there's two different types of graphs that the different experiments needed. So you have to use, based on your own judgment, which graph would best represent your data. So for massive water held, material used versus massive water held, they felt that a bar graph would best represent their data, which is why they used it. So there's no really specific graph that you have to use, but you just use what you think is the best. Okay. So then you have to also make sure you draw your line of best fit, as you can see in the left hand, which is also called the trend line or linear regression straight line that best illustrates the overall picture of what the collected data is showing. And yeah. It Yeah, it helps us to see if there's a relationship or correlation between the two factors being studied. Line of best fit it refers to a line through a scatter plot of data points that best expresses the relationship. Yep. Okay. Next, we have statistics. This is a very big one and the one that it's very easy to lose points on. Common ones, just at the top of your head, median, mean, median, mode, range. Use that on your data calculation, so you can see how they made a chart with mean, median, mode, range, outlier, and standard of deviation, which is kind of a complicated one to calculate, but it's very important to include because it makes like judges know that you like kind of know what you're doing. So here the formula of how to calculate standard deviation, but okay, so it's each value. Yeah, so wait one sec. Okay, so yeah, that's how you calculate. I don't know if you guys know how to calculate it, but that's how you calculate it. It's kind of like the sum. Yeah. Okay. I don't know. This is from last year. I don't really know why I included that, but you don't have to do that. It's fine. Okay. Okay. Analysis of claim, evidence, reasoning. This is the biggest chunk of it. It's the analysis of it's the biggest chunk. It's 18 points. So it's very important to do it. We have like a whole person when we're doing it. We have a whole person just dedicated for this because it's very easy to mess up, but it's very crucial in order if you want to get good points. In the statistics section, so you have to do three claim evidence and reasoning, one for statistics, one for outliers, and one for data trend. So the first one, statistics, is in the statistics section, there are several ideas you can observe. So You can kind of observe how there's not much variation in the data for one data set compared to another. For outliers, you can if possible you can try and force outliers into your data, but then yeah, but then you can talk about them here and other sections of experimental analysis. Um, Find data, like if you're going to force like an outlier, then you have to find data that you believe supports the fact that a certain point is an outlier, then explain it in reason. And like even if like you might not think there is an outlier, there usually will be. Or if not, you can make your claim that there is no outliers as long as you have data that supports the fact. The last one is data trend. Most data sets will end out with a data trend indicating some sort of correlation. Try and find this trend and use the claim evidence reasoning to explain it. This one would be helpful. The data tables that you created earlier would be very helpful in the data trend. Okay, so this is the example of our rebound height experiment. So as you can see, it covers everything up. It covers everything, all three of them. It is, wait, I don't, yeah, so you can give like a second to read that if it helps. Like you can see in the third paragraph, it says in the first independent variable level, there was an outlier. So it's using the data afterwards to back it up. Okay, I'll give one more minute to read. Today's topic is experimental design. If it's a inquiry, nature, science event, and science Olympiad, it's unlike most of the other events. This requires three people because it's obviously a lot more hands-on and requires more people to complete than study events or binder events. Okay, yeah. Let's move on to the next one. Possible experimental errors. Examining experiment and identifying two errors, how these errors affected results. It can be human error, except that's not really a good one to use. Experimental setup, etc., and it can be written in table or paragraph form. So I'll show you an example of both a table um, and a paragraph form. So okay, so here the first one on the left, you can see how they made like two errors. They talked about the specific error identified and they talked about how that error affected the results. You have to make sure you put the effect on results discussed, otherwise you're not getting the 8 points for this. You don't have to do a table format if you don't want to. You can, I mean, in in-person events, they might already have a table ready for you, but you can also write a paragraph. As you can see, this one is about like uh, water and like the water held experiment we saw. So that's kind of a paragraph covering that, but it covers the exact same thing, just in the paragraph format. Okay, these yeah, okay. The error section is often confused with the qualitative observations that we saw earlier. Um, the errors listed here must be precisely identified and their effects must be described, unlike qualitative observations where errors would be merely observed. Also, not all qualitative observations are due to errors. So that's like the kind of difference between them. Okay. What is the difference between qualitative observations and error? Because aren't you just observing both? So what's the difference? You're just yeah, okay. So observations are, yeah, they're noticing flaws in the experiment when, that went unnoticed. These include flaws in measurement technique, flaws in building, maintaining an experimental unit, and flaws in performing the actual experiment, but these carry over to experimental errors, right? Qualitative observations would just be errors, but they would just be merely observed. But these possible experimental errors, you have to make sure that explain them. Okay. Okay. Conclusion. You have to look about what your hypothesis is. You have to say what if it was supported or not if it was wrong or it wasn't wrong. It's either supported or not supported. It's about the claim. So you have to. So basically, to achieve the conclusion, you have to include your claim about the hypothesis, evidence, basically what your experiment data, and your reasoning why the evidence supports your claim. So like we saw earlier, the analysis of CER, you basically apply the same thing for conclusion, and you can see the rubric is just that. It's just the CER. They don't want anything more than that. So it should just be primarily be data based, use numbers, include numbers, and what you have observed. So here's an example. Conclusion, I can read it out. If a ball is dropped from different heights, then the ball dropped at the greatest height will have a greater rebound height. The data supported this hypothesis, with 1 meter drop heights averaging 81 centimeters, 2 meters averaging about 163 centimeters, and 3 meters averaging about 222 centimeters. Also, the graph showed a positive trend that had greater rebound heights when the drop height was greater. From these clear reasons, the hypothesis was accepted. So they covered all the CR stuff. Okay. Oops. Recommendations for future experimentations. This is the last part um, for writing your report. So how can you ask yourself the questions, how can you improve for more accurate results? A practical application of this experiment would be very good for future experimentation. So this rebound height thing can um, so that the so that like basketball, tennis are applied to the rebound height experiment. You have to think about a future experiment related to the dependent variable. So instead of measuring the rebound height, the measured variable could be how many times the ball bounces instead of the rebound height. So here you can see an example, recommendations for conclusions. This is where it's 6 points. You have to give suggestions to improve the experiment, suggestions for practical applications, and suggestions for future experiments. Yeah. So those three things are important to getting 6 points. Okay. Now we're gonna make our own with the 8 minutes we have with a different topic. So we have, this is an example. You're gonna use these materials. You don't have to actually do it, just make like a Google Doc, but I want you guys to copy paste it into chat once you're done at the end of our time. But use this experiment, use these materials. These are the only materials you can have. Remember, you can use a linear measuring device and like a ruler or a stopwatch if you need to. But your topic is buoyancy. So try creating an experiment with these materials and you should do like your statement of problem, your hypothesis, your materials, and your variables. Just do those four. I can type those in chat if it's helpful. Statement of problem, hypothesis. And remember, materials is not the same thing as the materials you see here because you're just writing about the materials that you're going to use for your experiment. So if you're not using those experiments, if you're not using some of the materials, you're not going to put them into your material list. Okay, so you guys can do that and try finishing by 4:40 and then send it to chat so I can read out some of them if you have it. Oh, it's on the screen already. Statement of problem, hypothesis, variables, and materials. That's what you're going to be doing with the materials given. And as soon as you're done, just send it to me in chat so I can see. Yeah, you can write, if you want to just write in the chat directly, that works as well. Um, yeah, some of these are good, but make sure for the hypothesis you include the rationale. Soap, you can use whatever soap you want as long as it's a bar of soap. Okay, I'll read out some statement of problems. So, one is how does salt and water affect water's density? That's good. Independent variable, dependent variable. Um, how does density affect buoyancy? Um, okay. Yeah, some of these are good, but remember for your question that it can't be a yes or no question. It has to be how independent variable affects dependent variable. So it shouldn't be yes or no. It should be how or what is the effect of. Um, So no yes or no, no question starting with the does. It should be what is the effect of or how how does blah 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 affect blah blah blah. Yeah, like one of them is good is like how do different elements and the amount of elements affect the buoyancy of a balloon? Except there's no balloon in the materials, but the question is good. Um, what is the effect of oil and salt and water? I saw one more. Yeah, materials are like water, 3 cups, oil, 1 paperclip, 1 marble. Yeah. Like even if you're using just 1 paperclip instead of the 5, you have to specify that it's 1 paperclip. You don't have to use all the cups. You don't have to use all of anything. You can just use whatever you need for your experiment. So it can be like you can use like 2 cups, 5 marbles, like that. What is the effect of marbles sinking in a cup with 8 ounces of water to 16 ounces of water? Yeah, you're comparing. You could use all 5 quarters if you wanted to, but you don't have to. If it's in the material list, you're allowed to use it. Okay, it's 4:40 right now, so you guys have a 10-minute break, and then we're gonna start Road Scholar.